Hello, this is Jared O-Ring at O-Ring Advisors. And today we're going to talk about renewable energy and some amazing engineering work that we need done. A hat tip goes out to Carrie Rippey, who is a researcher at the National Renewable Energy Laboratory for this story. In recent decades, the cost of wind and solar power generation has dropped dramatically. This is one reason that the U.S. Department of Energy projects that renewable energy will be the fastest growing U.S. energy source through 2050. However, it is still relatively expensive to store energy, and since renewable energy generation isn't available all the time, it happens when wind blows or when the sun shines, storage is essential. In a recent report, researchers at the National Renewable Energy Laboratory estimated that the potential exists to increase U.S. renewable energy storage capacity by as much as 3,000% by 2050. Here are 4 emerging technologies that could make this happen, and we need amazing engineers to do this work. Number 1, longer discharge time for batteries. For example, high-capacity batteries with longer discharge times, up to 10 hours, could be valuable for storing solar power at night or increasing the range of electric vehicles. Right now, there are very few such batteries in existence. However, according to recent projections, upwards of 100 gigawatts worth of these batteries will likely be installed by 2050. For comparison, that's 50 times the generating capacity of the Hoover Dam. This could have a major impact on the viability of renewable energy. Number 2, safer batteries. Another priority is to make batteries safer. One area for improvement is electrolytes, the medium, often liquid, that allows an electric charge to flow from the battery's anode or negative terminal to the cathode or the positive terminal. When a battery is in use, charged particles in the electrode move around to balance out the charge of the electricity flowing out of the battery. Electrodes often contain flammable materials. If they leak, the battery can overheat and catch fire or melt. Scientists are developing solid electrolytes, which would make the batteries more robust. It is something harder for particles to move around through solids than through liquids, but encouraging lab-scale results suggest that these batteries could be ready for use in electric vehicles in the coming years, with target dates for commercialization as early as 2026. Storing sunlight as heat is number 3. Other renewable energy storage solutions cost less than batteries in some cases. For example, concentrated solar power plants use mirrors to concentrate sunlight, which heats up hundreds or thousands of tons of salt until it melts. This molten salt is then used to drive an electric generator, much as coal or nuclear power is used to heat steam to drive a generator in traditional plants. These heated materials can also be stored to produce electricity when it is cloudy or even at night. This approach allows concentrated solar power to work around the clock. And finally, number 4, advanced renewable fuels. Batteries are useful for short-term energy storage, and concentrated solar power plants could help stabilize the electric grid. However, utilities also need to store a lot of energy for indefinite amounts of time. This is a role for renewable fuels like hydrogen and ammonia. Utilities would store energy in these fuels by producing them with surplus power, when wind turbines and solar panels are generating more electricity than the utility customers need. Hydrogen and ammonia contain more energy per pound than batteries, so they work when batteries don't. Longer discharge batteries, safer batteries, sunlight directly to heat, and renewable alternative fuels are potentially technologies of the future, and we need some amazing engineering to solve these problems.